Why physics is both simple and impossible. Physics is often described as the most fundamental science. It tries to explain the laws of nature, the way matter and energy behave, and the hidden structure of reality itself. On the surface, physics appears to be beautifully simple. The universe follows patterns, and these patterns can often be written down as mathematical equations. For example, Isaac Newton discovered that the same law of gravity that makes an apple fall to the ground also governs the motion of the moon and the planets. With one simple rule, Newton explained both the ordinary and the cosmic. This elegance makes physics look like a language of simplicity, a few clear rules explaining almost everything. The simplicity of physics is also visible in everyday life. The same principles of motion that explain how a ball rolls on the ground also explain how a rocket travels into space. The same conservation of energy that governs a pendulum swinging in your classroom also describes the fusion reactions inside the sun. This universality is what makes physics powerful. It reduces the complexity of the world into a handful of basic principles. And yet, the more we look deeply, the more physics feels impossible. At the quantum level, the world behaves in ways that seem to contradict ordinary logic. Particles can exist in two states at once, a phenomenon known as superposition. They can influence each other instantly across great distances, a mystery called entanglement. Even stranger, their behavior seems to change depending on whether or not we observe them. Quantum physics is not only difficult to understand, it seems impossible to truly imagine. Relativity adds another layer of impossibility. According to Einstein, space and time are not rigid backdrops, but flexible fabrics that bend under the influence of mass and energy. Time itself can move faster or slower depending on your speed or your position near a strong gravitational field. This means that reality is not the same for everyone, and the universe is stranger than any intuition we naturally have. The deepest challenge is that the two great pillars of physics, quantum mechanics and general relativity, do not fit together. Quantum theory governs the very small, while relativity governs the very large. But at places where both should apply, like inside black holes or at the beginning of the universe, their rules clash. Scientists have spent nearly a century searching for a theory of everything, a unifying framework that could merge the two, but the answer remains hidden. This makes physics feel impossible, not because we lack intelligence, but because the universe itself may be stranger than human logic can handle. And yet, it is precisely this impossibility that gives physics its endless fascination. Every time we solve a mystery, new questions appear. When Newton explained gravity, it raised the question of why gravity exists at all. When Einstein explained relativity, it raised questions about the nature of space and time. When quantum theory revealed the strangeness of particles, it raised questions about the very meaning of reality. Physics never ends, because every answer is also a doorway to deeper mysteries. So why is physics both simple and impossible? It is simple because the universe obeys laws that can be written in elegant and often beautiful equations. It is impossible because the full depth of those laws lies beyond our current imagination, challenging us to think in ways that stretch the limits of human understanding. Physics is the balance between clarity and mystery, between simplicity and impossibility. And perhaps it is this paradox that makes physics the most human of sciences, forever searching, forever wondering, forever reaching toward the truth.